Hi guys, as promised, I'm going to talk about Poisson distribution. It's very, very simple, and also, you know, your exam is all calculator. I think you have 45 or 50 questions. I don't remember how many questions you have on there, but your exam, your semester exam is all calculator, and you're going to get to use your calculator for everything, and even on the IB exams, these are all calculator problems. So anyway, this is very simple to learn. You just have to really know the conditions. It's very similar to binomial, and let's go over that, so that way if you have any questions on the exam, and I'm sure you will on Poisson, then you'll be able to answer them. Okay, so conditions for Poisson. Okay, the occurrence of the event at a particular point in space or time is independent of what happens elsewhere. The probability of an event occurring within a small fixed interval is constant. So we're thinking about events that occur like in a time interval, like maybe you're waiting in line at Target to pay for what you purchased, and there's, you know, 3 people ahead of you, that kind of thing. The other condition is that there's no chance that 2 events will occur at precisely the same moment or in time or at the same place. Okay, so these are the 3 conditions for Poisson, and you know, this is infinite. It's not finite like the binomial. Okay, if an event is randomly scattered in time or space, the discrete random variable x that models the number of occurrences in a given interval follows a Poisson distribution with parameter m. Now, a lot of times, this m, this is just from your book, so that's why I'm using m, but a lot of times, most often, a lambda is used for that. So you might see it like this also, with a lambda. Okay? So the discrete random variable x follows a Poisson distribution with parameter m, or lambda. The PDF of x is f of x is equal to p of x equals to x, and the formula is right here, e to the minus lambda, or e to the minus m, times m to the x over x factorial, where x is 0 up to whatever. Okay? The Poisson CDF is same thing, except so cumulative distribution, right? So it's accumulating area below and up to this value of x. Well, that's just the sum, right, of all the little probabilities. So from, let's say, t equals to 0 to x, it's e to the negative m, m to the t over t factorial. So same exact formula. Okay, so let's look at some examples. There's only 2 possible examples you could have for your semester exam anyway, and so we're going to look at those, and then I'll have you practice. So this is going to be a real quick video because it's that easy. There's really not that much at this point to do with these things. So here we have a Poisson distribution with a parameter of 2, and they want you to calculate the probability that x equals to x for all of these values of x. Okay, so again, you have to use your calculator, and I put what to do there, but you know, it's second vars. And you go to Poisson PDF, okay, PDF, and press enter, and so you see your calculator uses lambda. All right, so if my parameter is 2, that's what I'm going to plug in there, and now I need to compute when x is equal to 0, so you plug a 0 in there, and you get 0.135. Okay, I'm going to just press enter again, and that'll second enter, and that'll copy and paste. And now I want to know, you know, what this is when x is 1, and it's 0.271. Second enter, I want to know when x is equal to 2. Okay, second enter, 0.271, and so on and so forth to get those values. Okay, and I put down here, you know, your second variable's Poisson PDF, and then just put your parameter, and then whatever value of x, and hit the enter key, and that's going to give you a value. Okay, so I wanted, you know, p of x equals to 7 or something, then I'd put 2 comma 7 under Poisson PDF, and that would give me, so remember, this is the exact value, right? Now, sometimes they're going to ask you to find m. They're going to give you some information, and they're going to want you to find some things here. So we have a Poisson distribution with parameter m, and the probability that x equals to 0 is 0.2. The first thing they want us to do is find m. Super simple to do. So probability that x equals to 0, or that x equals 0 is 0.2, all I have to do is say, well, you know, this is e to the negative m times m to the 0 over 0 factorial. In other words, whatever this x value is that I want to record or figure out, I'm plugging in for x is in the formula, and I set it equal to what is equal to 0.2, right? This is a 1, this is a 1, so I'm left with e to the negative m equals to 0.2. Take the natural log of both sides, so ln e is going to cancel. I'm left with negative m is equal to ln 0.2. So m is equal to negative ln 0.2, which is 1.61. So my value of m is 1.61. In part 2, they want us to find the probability that the random variable x takes on values less than and equal to 4. Well, that's p of x equals to 0 plus p of x equals to 1 and 2, 3, and 4. Okay? But rather than that, I don't want to deal with all that. Okay? So all I have to do is use my calculator. And do 1.61 and 4. So I want you to notice something. Because I have an inequality now, it's not an exact value. You notice on my calculator, oh sorry, I plugged it in without putting it under the camera all the way. It's Poisson CDF. It's going to accumulate or sum up all of those probabilities, okay? I put my parameter m, which we just found to be 1.61, and I put the highest value that they want us to compute up to, and we get 0.976. That's it. You're either going to find m, or you're going to find the accumulation of probabilities, the sum of the probabilities for something like that. That's all you need to know. Okay, so I'm going to put a few little examples, IBQs, up for you to practice with the mark scheme for tomorrow. And if you have any questions, please don't hesitate to text me. And do my cell phone too. When you text the remind, sometimes I shut off the beep and now I can't figure out how to turn it on. So I just check it periodically, but if you text me at 813-418-2854, then I'll get the message immediately and then I can respond immediately. Capiche? All right, have a great day.